here we have a few questions from wave motion coming up. Looking at the first question, it goes like this. The equation of a progressive wave is given by this particular equation: y is equals to a sine pi t by 5 minus x by 9 plus pi by 6. This is the equation of the wave that's given, where x and y are in meters. Then which of the following is true? Velocity is 5 meter per second. So velocity of wave. First of all, let's try reducing the quantities. This is 4 sine. So here amplitude is 4 meters. So this option obviously goes wrong. And standard equation is y is equals to a sine omega t minus kx plus phi, right? So just comparing the terms, I'll get omega is equals to pi by 5 and I'll get k is equals to pi by 9, right? So if you need the wave velocity, that's given by omega by k, so that's pi by 5 divided by pi by 9, so that's 9 by 5. So that's obviously v is wrong. Let's look at the wavelength. 2 pi by lambda is my k, and that's according to this pi by 9. So just cancel the pi and your lambda becomes 18 meters. So obviously option 2 is right. And because you know what omega is, it's pi by 5 and it's nothing but 2 pi f. So from here you can get f also, and that will be nothing but 1 by 10, right? 1 by 10 hertz, and that's obviously not the right option. So option 2 is right. Let's move on to the next problem now. The equation of a wave given by this equation: y is equals to 5 sine 10 pi t minus 0.01 x. Right, this is along the x-axis, right? All quantities are measured in the SI units, the phase difference between the points, right? So how do you get the phase difference? Delta phi, phase difference between 2 points, is given by this equation: 2 pi by lambda into delta x, where this 2 pi by lambda is nothing but your k, which is your wave number, k lambda x. So let's get the k from here. So the standard equation is a sine omega t minus kx. So just compare the terms. Your k will be nothing but 10 pi into 0.01, right? This is your k, and delta x is given to you in the question. That's 10 meters, because it said that they are separated by 10 meters. So from here you can get delta phi, that will be equal to 10 pi into 0.01 into 10. So it's very, very simple. It's pi. The phase difference between the 2 points being talked about in the question is pi. Moving on to the next question now. The angle between wave velocity and particle velocity in a traveling wave may be, right? So first of all, remember, there are two kinds of waves. Whenever there are two kinds of velocities which are associated with a wave. So a wave is nothing but displacement of particles, right? So these particles might be having their own velocities, whatever, but it seems that as if this wave is moving forward with some common wave velocity. So what you need to understand is the wave velocity is very different from particle velocity. Particle velocities are different for every particle, but wave velocity is the same for the entire wave, right? Particle velocity is basically particles actually moving, actually getting displaced or showing some sort of an oscillation, and every particle showing the oscillation has some particle velocity. But this phenomena of oscillation of particles gives rise to the phenomena of a wave actually moving forward. There's nothing moving forward actually, but when you take pictures of this wave at every small instant of time, it will feel as if this wave is moving forward, and it will feel as if the wave is moving forward with this wave velocity. The wave velocity is common for the wave. So angle between wave velocity and particle velocity in a traveling wave can be all of these. It can either be zero, that means your particle might be moving in the same direction as your wave, so in that case the angle between the velocities will be zero. It might also happen, as in case of a transverse wave, when your particle is moving up and down but your wave is seeming to be moving forward. So in that case the angle between the velocities will be 90. So pi by 2 is also possible, 0 is also possible, and it's also possible that for longitudinal waves that some of your particles are moving backwards but your wave is still seeming to be moving forward. So at that instant the wave velocity and particle velocity are having a phase angle of pi. So all these angles are possible. That's the answer to the question. Let's move on to the next problem now. A source oscillates with a frequency of 25 hertz. So the source is oscillating with a frequency of 25 hertz. The wave propagates with a velocity 300 meter per second. So wave velocity is given 300 meters per second. 2 points A and B are located at x equal to 10 meter and x equal to 16 meter respectively. That means this is not kilometer, it's meter, right? So that means the difference between the 2 points, the distance between the 2 points is nothing but 6 meter, right? 16 minus 10. Now the phase difference between A and B is, right? So this is your point A, point B. So as I told you in the previous, in one of the previous problems, phase difference is given by this formula k delta x, or 2 pi by lambda into delta x. Delta x is something that's already given in the problem. It's 6 meter, but k is what you need to find out. So using this data, I'll find out k. Let's see how I can do that. Velocity is nothing but frequency into lambda, right, for a wave. So frequency is given, velocity is given 300, frequency is also given 25, right? So it's 25. Lambda is not given, so you can find out lambda from here. It's 300 by 25, which is 12, right? K is nothing but 2 pi by lambda, which is 2 pi by 12 into 6. So when you solve this, your delta phi is nothing but 12 pi by 12, which is pi. So the phase difference between the 2 points, which is talked about in the question, is nothing but pi. Let's move on to the next problem now. The equation of a transverse wave propagating in a string is given by this particular equation. So this is the equation of the transverse wave. 0.02 sine x plus 30t. So you can make it analogous to y is equals to a sine kx plus omega t, right? X and y are in meters, t is in seconds. If the linear density of the string is given to you, mu, which is the linear density of string, 1.3 to 10 power 5 minus 4 kg per meter, then what is the tension in the string? Well, what you need to understand is the velocity, wave velocity also has another formula, that's root tension by mu. That means if I have a certain tension in the string and the string has some linear mass density as mu, then the wave velocity on the string is fixed to be root t by mu, right? So using this equation I can find the wave velocity. Let's see how I can do that. K is nothing but 1 and omega is nothing but 30. So velocity is nothing but omega by k, which is 30 by 1, so it's 30. 30 meter per second is the velocity. So from here t is equals to mu v square. You have found out v, which is 30 square, which is 900, and mu is given to you already in the question, 1.3 into 10 power minus 4. So using these two you can get the value of tension. So when you solve it, you'll get tension approximately equals to 0.127. So it's very, very close to, in fact, exactly equal to 0.127. So very, very close to 0.12. So the answer to the question is 0.12 newtons. Let's move on to the next problem now. The speed of propagation of a wave in a medium is given by 300 meters per second. So there is a wave which is moving ahead with some 300 meters per second. The equation of motion at the point x equal to 0, so this is your x equal to 0. It's given to you like this. Y is equals to 0.04 sine 600 pi t, right? Let me just check the question. Yeah, forget about this 9. There's no 9 here. It's just 0.04 sine 600 pi t meters, right? This is for x equal to 0, right? So your wave equation must be something like y is equals to a sine omega t minus kx, wherein if you put x equal to 0, then you'll get this. So from here I can straight away say that my a is 0.04 sine, my omega is nothing but 600 pi, and k is what I need to find, right? K is what I need to find. So how do you find k? That's the question. Well, omega is something that you got. It's 600 pi, right? So this is nothing but 2 pi f. So from here you can get the frequency. Frequency is nothing but 600 by 2 pi. 600 pi by 2 pi is just 300 hertz, right? And your velocity is also given to you. It's 300 meters per second. So from using this, you can, using these two things, you can get lambda, because f is equals to v by lambda, right? Or v is equals to f lambda. So from here you can get lambda is equals to v by f, which is 300 by 300, right? So it's nothing but 1. So lambda is 1 meter. So your k is nothing but 2 pi by lambda, which is 2 pi by 1. So your k is 2 pi. So you've got your k also. This is 0.04 sine 600 pi t minus 2 pi x. So this is the entire equation. Now you need the displacement of a point at x equal to 75 centimeter and t is equal to 0.01. Just put these two values in this, you'll get the displacement. So y is equals to 0.04 sine 600 pi into t, 600 into 0.01, which will give you a 6 pi. So you have a 6 pi minus 2 pi into x. X is given to you as 75 centimeters, so it's 2 pi into 75 by 100, right? So it's using this you can get y is equals to 0.04 sine 6 pi minus 150 pi by 100, which is 1.5 pi, right? So it's nothing but 4.5 pi, 9 by 2 pi. So y is equals to 0.04 sine 9 by 2 pi. This sine 9 by 2 pi will become 1 and you'll get your y to be 0.04 meter. So the answer to the question should be option B. It's 0.02 meter. That's how simple the problem was. Sorry, it's not 0.02 meters. It should be 0.04 meters. Yeah. So that's how simple the problem was. You just need to know how to write the equation correctly. The second question goes like this. Seventh question. 100 hertz sinusoidal wave. So frequency of wave is given to you 100 hertz. So whenever it comes to wave motion, just look at the problem, look at the data and start writing the data. You just have to use one or two equations at max to solve the problem. F is equals to 100 hertz. It's traveling in the positive x direction. So it's traveling in the positive x direction. It's having a linear mass density. So mu is given to you. Mu is nothing but 3.5 into 10 power minus 3. It has a tension. Tension is also given to you, 35 newtons, right? At time t is equal to 0, the point x equal to 0 has maximum displacement in the positive y direction. Next, when this point has 0 displacement, the slope of the string is pi by 20. So slope of the string is given to you. It's nothing but pi by 20. Then which of the following expression represents the displacement of the string as a function of x and t. So you need to find this. Y is equals to a cos omega t minus kx here. Like this will be the form that it will take. And the reason for that is at t equal to 0 and x equal to 0, it's having a positive maximum displacement. So if you had a sign here, then y would become 0. That's why you need to take a cos, because if your x equal to 0 point at t equal to 0 is having maximum displacement, then you can't afford to have y is equals to a sine omega t minus kx. Then this model doesn't work. You need to take y is equal to a cos omega t minus kx for such problems, right? So that's why the options are like that. You have this data, and using this data you need to find everything. So what is the equation that we'll use? We'll use this equation. Basically the particle velocity is nothing but omega into amplitude. So what I need to find right now is amplitude. Omega into amplitude should be equal to my particle velocity, and particle velocity also can be written in this form. It's nothing but wave velocity into slope, dou y by dou x. That's actually one of the fundamental laws of traveling waves, that your particle velocity can be written related to wave velocity in this particular manner, wave velocity into slope. So this negative sign isn't really significant here. I can just take the magnitude because it just represents direction, right? So what I'll do is, to get the magnitude of amplitude, I'll do this velocity into dou y by dou x, which is slope, divided by omega. So everything is there. I need the velocity. Velocity is nothing but root t by mu. So t is given, mu is given. So root t by mu is nothing but velocity. So this is nothing but root 35 divided by 3.5 into 10 power minus 3. This is velocity into slope is given to you, pi by 20 divided by omega is also given to you because frequency is given. So if f is given, which is 100 hertz, omega is nothing but 2 pi f. So it is nothing but 200 hertz, right? So 200 here. So when you solve all of this, you'll get your amplitude to be 0.025 meter. So obviously option 2 and option 4 are eliminated because the amplitudes should be equal to 0.025, and that's happening only in option 1 and 3. So eliminate 2 and 4. Now the only thing that I need to find is I need to find omega, right? Because frequency is given. So omega is 2 pi f. So its omega is nothing but 200 pi. So the coefficient of t should be 200 pi, and that's only in option 1, because option 3 it's 100 pi. So this also can't be right. The only correct option is option 1. So that's how simple the problem was. Let's move on to the next problem now. Vibrations of a period 0.25 seconds. So time period of vibrations is given 0.25 second. That means immediately the frequency is given because it's 1 by t. So 1 by 0.25, so it's 100 by 25, which is 4 hertz, right? So all of this data is given right away in the first 4 words of a sentence, right? Propagates a straight line at a velocity 448 centimeter per second. So velocity is given, velocity of the vibration, that means indirectly the velocity of the wave is given to you, 48 centimeter per second. 1 second after the emergence, 1 second after the emergence of the vibrations at the initial point, the displacement of the point 47 centimeter from it is found to be 3 centimeter. That means at x equal to 47 centimeter and t is equals to 1 second after the emergence, that means at t equal to 1 second, your displacement is found to be 3 centimeter, right? So this is another data that's given to you. Now what you need to find is the amplitude of the vibrations, right? So how do you do that? Let's actually check that out. So let's first find omega. Omega is nothing but 2 pi f. F is already given to you, 4 hertz, so it's nothing but 8 pi, right? Velocity is given to you, so you can also find k. K is nothing but omega by v, right? It's nothing but it's 8 pi divided by 0.48, right? 8 pi divided by 48 into 10 pi minus 2, which is 0.48, so which is nothing but 50 by 3, right? That's your k. So now you will put this in the equation y is equals to a sine omega t minus kx, because here it's assumed that initial point in its mean position is in its mean position at t equal to 0, right? So at t equal to 0, your x is equal to 0, and that will happen at t equal to 0 and x equal to 0, your y is equal to 0. That's so whatever is given in the bracket actually means this. And when that happens, you will take y is equals to a sine omega t minus kx. You won't take a cos omega t minus kx. You will take cos only when this y was equal to a. But that's not the case here. Your y is given to be 0. It's assumed to be 0. So so now what you do is you have y is equals to a sine omega is given to you 8 pi t. K is given to you 50 by 3 x. So now you'll put this data in this equation to get the value of amplitude, right? So that's what you'll do. So let me just put the data and show you how to get the amplitude. Yeah. So y is given to you 3 centimeter. A is something that you don't know, so let that be sine 8 pi. T is given to you, it's 1 second, minus 50 by 3 into x is given to you, right? And x is having a value of 47, right? So using just this one equation is present with you. So don't worry about the sine value. Most likely if you get such a question in the examination, sine of whatever you get here will be already given to you in the question. So when you solve that particular thing out, you get the value of a to be almost equal to 6 centimeter, right? So don't worry about this quantity inside the sine. Like they'll obviously give that in the question. They won't expect you to actually know that. So it's option 1, 6 centimeter. Let's move on to the next problem now. Transverse waves are generated in 2 uniform steel wires A and B by attaching their free ends to a fork of frequency 500 hertz, right? So there are 2 strings A and B, and they are both attached to the same source, so 500 hertz. That means 500 hertz frequency vibrations are being sent in both of them, right? The diameter of A is half of that of diameter of B. So diameter of A is half of diameter in B, and tension in A is half of that of tension in B. So tension in A is half of that in wire B. So now the velocities of in wire A and B are given as, right? So velocity is nothing but under root t by mu. That's the formula for velocity, right? So mu can also be written as rho into s, right? Because it's nothing but mass per unit length, right? And the density rho is nothing but mass by volume, and that into area will actually give you mass per unit length. This s is your cross sectional area, by the way, right? So I'll just substitute these 2 quantities. So this is under root t by, because it's steel, rho is same for both of them, and this area is nothing but pi d square divided by 4. So I can say velocity is directly proportional to root t by d, right? So VA divided by VB can be written as root TA by TB into dB by dA. So this is how you'll get the velocities ratio. So VA by VB is nothing but root TA by TB root which is under root 1 by 2, and dB by dA is 2, so it's nothing but root 2 is your answer. VA is to VB. Solving this particular thing is nothing but root 2 is to 1, so answer to the question should be option 2. Let's just check that out. Yeah, it's option 2. Moving on to the final problem now. The frequency of an A note, so you have FA is equals to 4 times of that of B note. FA is equal to 4 times of FB. The energies of these two notes are equal, so EA should be equal to EB. The amplitude of note A as compared to that of B will be, so you need AA is to AB. So you first need to know the formula for energy. What all does it depend upon? So what you need to know is your energy is directly proportional to omega square A square. In fact, it has a weird sort of a formula, half rho omega square A square SV, something like that. But the rho will be the same because the material is the same, area of cross section will be the same, V will be the same because everything is the same. It's only that the frequency is differing, so omega will differ, and your amplitude is what you need to check. So EA is equals to EB, that's given in the problem. That means omega A AA square should be equals to omega B AB square, right? So we cancel this out. Your AA this AA is not equal to AB. This is a wrong statement. We actually need to find the relation between AA and AB. So AA divided by AB is nothing but omega B by omega A, which is nothing but 2 pi FB divided by 2 pi FA. So AA divided by AB is nothing but FB divided by FA. So FB by FA, from here if you solve FB by FA, that's nothing but equal to 1 by 4. So amplitude of A divided by amplitude of B is nothing but equal to 1 by